Welcome back again to another video lecture in C++ programming language. And in this video lecture, we're going to look at data types. Alright, so these are data types known as data type, and as a developer, you will always save things inside somewhere, and they're called variables. So these are like a container, they're placeholders, where you can be able to save some things and then you go back and retrieve them anytime you need it. So as a developer, you might want to save things like integers, floats. When I mean floats, I mean decimal points. You want to save names, the ARG strings. You want to save characters like A, B, C, D, so you can always reference to them. So you save these right inside variables, and these variables have different types. So if you want to save integers, use what is called int. If you want to save floats, that's decimals, use what is called float or double. If you want to save characters, use what is called char. And then plus and minus, use what is called boolean. So we have different data types. So the first one among these data types is boolean. So boolean is for plus or minus. Okay, so this is what it takes, but it's plus or minus. Then the next one is character. You call that char. You call that char. So anytime you see boolean, you see character, you replace that with char. Just like boolean is represented with bool, so we'll not be calling boolean, but if you want to pronounce that, you say it is boolean. But you want to use that in your program, you use bool. Just like character, you can pronounce character and use char to represent it in your program. Then the next one is integer. If you want to save variables of integer, you use int and not integer. So you can say int x, int y, int z. Alright? Then the next one is floating points. So the floating points are decimals. They are known as floats. So you can use float x, float y, float your name, float my name, float hash, float this or that. Then the next one is double floating point. They are represented with double. Alright? They are represented with double. So you always use double. Okay? So double is what you're going to use. The next one, this is float, is what I'm going to use. Then integer is what you use, and bool is what you use, and that is something with character. So I believe that is good. The next one is valueless, that is void. So when you use valueless, void, it means it is not going to return anything. So these things have their memories. So whenever you're saving something in a computer, it means you're sending that to one particular memory. And those memories have range. They have different sizes. Each time that size fills up, nothing can ever be saved right in there. So whenever you want to save things, you want to save your character, integer, float, you should know the size of that location so that you add things that are within that range. Okay? The reason why we have floating point, and double floating point is that floating point it has low memory size to compare with double floating point. The size of this double floating point is bigger than the floating point. And for integers, we have signed int, unsigned int, long, and so on. And almost all these data types, they have different modifiers, like the signed, unsigned, and short. So the same thing is applicable to float. It has both signed, unsigned, and short. And that same thing is applicable to any one of them. Now let's go ahead and focus on the values. Or I mean the range and their bandwidth. Okay? Let's look at the range and the bandwidth. So for character is just 1 byte alone. So the size of the character is 1 byte, and the range is from -127 to 127. -127 to 127 is what it can hold, or 0 to 255. So this is the memory location of this, and the size of what it can hold is 0 to 255 for the memory. The next one is the unsigned char. Unsigned char is still 1 byte, so I don't see the use of char, unsigned char, at the same time because it's just the same memory size. Except if the first one is filled up, you can then use the second one. Then we have signed char, just exactly the same size and the same range. Okay, now we have integer. So you can use integer, and this integer is for integer variables alone. So we use int for integers, okay? Int, and the size of this is just 4 bytes. Let's go 4 bytes and look at the range of this. The range is from negative this range to this range. That is 2147483648. So for negative side of this to this is considered the size really too big, too many. Alright? So it's really so much. So the next one is unsigned int. So this is unsigned int, not unsigned only. So this is unsigned int. It is still 4 bytes. Then the size is 0 to this size. So it doesn't take negative values, okay? For the unsigned int, it doesn't take negative values. So you have to put that in mind. Alright? So the next one is signed int. Signed int is 4 bytes as well. The range is just like the same with int. Alright? Just the same with int. You can see the size it holds. Can you see that? Just the same. The next one we have, let's go ahead and look at another, the short int. So the short int is 2 bytes only. 2 bytes, and the size is negative 32,768 to positive 32,767, and not 68. Alright? So this is the size of the range of short int. So the next one is long int. Long int is 4 bytes. And this is the size. Okay, so we consider long int is bigger than the short int. The short int is very smaller. Check it out again. Short int is, that's 2,768. And why this is so long? Now, the float. The float is 4 bytes. Okay, you can see it's bigger. It's 4 bytes just like a integer. Then the range is plus or minus 4.3.4 exponential plus or minus, that's it. It takes approximately 7 digits of decimal point. So this is approximately 7 digits of decimal point for float. Okay. Then we have double. Double is 8 bytes. You can see double is really bigger. It's really bigger than our float. And the range of double is plus or minus 1.7 exponential plus or minus 308. And it takes precision, that is decimal points of approximately 15 digits. That is really so great. Alright. So the next one we have is long double. So long double is still 8 bytes. And the size is approximately plus or minus 1.7 plus or minus 308. Okay. Then it's approximately 15 digits. That is the decimal point. I hope that is very cool. So, this is about the data types. You can see the data types we have, the long double, we've checked the range. We have double, we have floats, we have long, we have short end, we have signed end, unsigned end, then integer, signed char, unsigned char, char, and valueless, got the void or so on. So let's go ahead and print out the values of these on our system. Okay, and more tissue because we've checked all these and we've seen the byte size. Let's go ahead and print them out to make sure this is really the size. Okay, so I'm going to press these with the data types. Let me change this to data types. That is what we're doing. Data type sizes. So now let's go ahead and I'm going to copy this. Let's give a space. I'm going to say out. Then for me to do this, I'll go ahead and say so memory size of char. So memory size of char equal to or is. Let's move that to be equal to. Then if you want to print out that, you go ahead and put this and say size of. You see that? Size of char. Put it size of char right in there and end that. End line. So now I'm going to copy this. I'll press this so we can be typing this one by one and we can be able to minimize our time. Alright? So press this for integer, for short end, for long end, for float, for double. Okay. So memory size of chain now, let's go ahead and say memory size of end. So if you come back here, you say size of end. Put that down on your own system so you can be able to work around with me. Then memory size of short end and come right in there and put size of short end. So I'm going to explain this before we print them out, okay? So memory size of long end is equal to long end. Then memory size of float is equal to size of float. Then memory size of double is equal to size of double. Alright, so now this is just a string value to show what I'm going to print out: memory size of char, memory size of end, memory size of short end. Then this is a function. This function helps us to print out the size of whatever we want. Okay, so this function helps us to print out the size of whatever you ever want to print out. So if you want to print out the size of char, double, float, you go in there and put in size of, then inside the parentheses you put in whatever you want to print out its sizes. It will bring it out for you. It's an import function right inside C++. And let's go ahead and run this code, and we're going to compare that with what you've learned so far and know if that it actually works out fine. Okay, so that is coming. I believe within a short time is going to pop up. Now let's compare this, okay, with what we have already known. So we say memory size of char is equal to 1, and that is 1 byte. Okay, so this is 1 byte, 4 bytes, 2 bytes, 4 bytes, 4 bytes, and 8 bytes. Now check it out. Char is 1 byte. Can you see that? And that That is what the system gives you. And word of integer. Let's check integer. Integer is 4 bytes, and the size of integer is 4 bytes. And the word of short int, let's check it out. Short int is 2 bytes, and see that? 2 bytes. And long int, check it out. Long int is 4 bytes. Can you see that? Then float is 4 bytes, and double is 8 bytes. Can you see that? It's exactly the same thing that the system gives you. So I believe that is really working out very fine. And we can start now to start making use of the data types as we move on into the system and begin to build some awesome projects that will help us to master C++ programming. So go ahead and put this down on your own system. Try to print out the sizes of these data types using your own program, and it's going to work out fine. And in case if you have any question, please go ahead and use the question and answer sections, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture.